When you see the P-38 Lightning in photos, it looks like a plane from a sci-fi sketch. Twin booms, a central nacelle, a nose bristling with guns. It's dramatic, iconic, almost unstoppable on paper. But the real story behind the Lightning is messier, stranger, and far more instructive than the heroic postcards. This is the shocking truth they hid behind the P-38, a masterpiece of design that only became legendary because pilots, engineers, and ground crews constantly fought to make it work in the real world. Let's start with the obvious advantage, the P-38's layout. Putting all the firepower in the nose, no synchronized wing guns, no convergence, gave it instant, lethal punch at any range. Twin Allison engines coupled with turbo superchargers delivered high-altitude speed and range other fighters simply couldn't match. That combination wasn't cosmetic, it was tactical. The Lightning could escort bombers, fight at altitude, and then turn into a long-range interceptor or strike fighter. In the Pacific Theater, that range and altitude made missions possible that other fighters could only dream of. But design brilliance came with trade-offs. The P-38 was complicated. 2 engines, complex turbo systems, intercoolers, and the plumbing that tied them together added weight, maintenance time, and a long list of failure modes. In forward fields and on primitive Pacific strips, keeping those systems healthy demanded inventory, skilled mechanics, and time, all in short supply. The Lightning could dominate an air battle, but only if its engines and turbos were cared for properly. That logistical tax is the first hidden truth. The P-38 was not plug and play. It required an industrial tale that many squadrons learned to respect the hard way. There's a second truth few documentaries stress. The P-38 arrived to combat with real teething problems. Pilots discovered dangerous behavior in high-speed dives and at altitude, control issues that could surprise even experienced flyers. Those problems weren't mystical. They were the limit of aerodynamic knowledge at the time. Engineers responded with design tweaks, flight procedure changes, and pilot training. The Lightning didn't instantly conquer the skies. It evolved into a great plane through iterative fixes and hard lessons learned at the cost of lives and aircraft. That leads to another hidden layer. Tactics won the technology. The P-38's strengths had to be turned into doctrine. In the Pacific, crews used its long legs for intercepts, reconnaissance, and the famous mission that changed the war's course, the interception that killed Admiral Yamamoto. That was not luck. It was planning that exploited the Lightning's unique reach. In Europe, however, the P-38's advantages were less consistent. Cold weather, different maintenance infrastructure, and the tactical environment reduced some of its edge. The truth: a brilliant aircraft still needs the right war and the right support to shine. Human skill amplified the Lightning's promise. Top aces like Richard Bong and Thomas Maguire learned to use nose firepower, energy tactics, and boom and zoom attacks to devastating effect. But the P-38 also punished mistakes. Uncoordinated throttle use, neglect of turbo systems, or sloppy field maintenance could and did strand aircraft. The plane rewarded discipline and punished improvisation. That's the uncomfortable fact. Its glory is as much about the men who manage complexity as about the engineering on the drawing board. There's also a political and industrial truth. Lockheed produced an innovative aircraft, but wartime priorities and production realities shaped which versions were released and when. Some late-war P-38s incorporated significant improvements, better intercooling, strengthened structures, and refinements to handling, but those arrived after lessons had already cost crews dearly. In short, wartime development is an ugly relay between designers, factories, and operators, and the P-38 shows how that relay can make or break a machine's reputation. Let's not romanticize its successes without admitting its costs. The Lightning's twin-boom silhouette made maintenance access awkward in places, spare parts logistics were heavier, and early models were prone to certain failures in extreme climates. Allied planners had to decide when the P-38's range and firepower justified tying up scarce mechanics and parts in the front line. That calculation changed theatre to theatre and campaign to campaign, which is why the P-38's legend is so geographically split. Yet when conditions were right, the Lightning's impact was undeniable. It excelled at high-altitude interceptions, long-range photo reconnaissance, and missions no single-engine fighter could perform. Its concentrated nose armament made it brutally effective against bombers and shipping, and its twin engines gave a survivability many single-engine fighters lacked when hit. Those operational realities explain why commanders kept investing in it despite headaches on the ground. One overlooked factor in the P-38's success was its adaptability. The same airframe that started as a high-altitude interceptor evolved into a fighter bomber, photo reconnaissance platform, and even a night fighter. The F-5 variant, stripped of guns and packed with cameras, became one of the most valuable intelligence tools of the war. Its ability to climb higher, fly farther, and stay longer over targets gave Allied planners the insight they needed to plan entire campaigns. That flexibility, born from design foresight, made the Lightning more than a combat machine. It became an information weapon. Another rarely mentioned truth lies in its technological legacy. The Lightning's twin-engine configuration, turbo supercharging system, and emphasis on centralized firepower directly influenced post-war jet design. Engineers who worked on the P-38 carried lessons forward into aircraft like the F-80 Shooting Star and later the F-104 Starfighter. Even concepts like redundancy, energy retention, and climb performance metrics in modern twin-engine fighters owe roots to experiments first proven in the P-38. The Lightning wasn't just a wartime tool, it was a bridge to the jet age. And finally, the emotional truth, the human connection that defines its legacy. Pilots often describe the P-38 as having a personality. It demanded respect. It punished arrogance, but rewarded patience and skill. Those who mastered it developed a bond with the aircraft that went beyond machine and pilot, a partnership of trust in the harshest environments imaginable. That bond, forged through adversity and technical challenge, is what turned the Lightning from an engineering project into a legend remembered with pride and awe 8 decades later. So what's the bottom line? The shocking truth. The P-38 was neither a miracle nor a gimmick. It was an advanced, demanding tool that revealed 2 eternal lessons of war. First, technological advantage depends on logistics and training. Second, initial genius on the drawing board must be matched by iterative fixes in the field. The Lightning became legendary not just because of its design, but because people adapted, fixed, trained, and fought with it until it could deliver on its promise. If you take one lesson from the P-38 story, remember this: hardware alone doesn't win battles. The plane that looks like a miracle on paper becomes a legend only after mechanics fix its bugs in muddy airstrips. Pilots learn its quirks under fire, and commanders shape missions to exploit its unique strengths. The Lockheed Lightning gives us a clearer truth about aviation in war. Brilliance needs backing, supply chains, training, risk tolerance, and the grit to turn prototype problems into battlefield advantage. That's the truth they often hide behind the images of gleaming P-38s, a masterpiece that demanded mastery.